Here's part 2 of chapter 5, and this is just a short section really focusing on electrolyte imbalances and water balances. So, 3 different objectives for this part, looking at the terminology associated with deficits or excess amounts of some of the different important electrolytes, and then looking at the causes of abnormal levels of the major electrolytes. And then skipping ahead to objective 9, it's out of order just a bit. You want to be able to understand the relationship of renin to aldosterone and the different components in between those two. So, sodium and chloride balances, critical for maintaining water balance within the body. If you remember that sodium and chloride, or salt, are the primary extracellular fluid electrons, or electrolytes. These are going to regulate extracellular osmotic forces, osmotic indicating water, and in doing so, is going to regulate water balances. The renin-angiotensin-aldosterone system is crucial it's a crucial system of chemical communications that are going to work throughout the body to maintain proper vascular fluid volumes and therefore regulating blood pressure. And we'll look at that on the next slide. Natriuretic peptides are produced primarily by the heart. Different types of natriuretic peptides are produced by different parts of the heart, as well as a couple of different types by the kidneys. The natriuretic peptides are produced when pressure within the heart or kidneys increases, and those promote urinary excretion of sodium and water, which then causes the blood pressure decrease, lessening or really causing the blood volume to decrease, which lowers the blood pressure to lessen the pressure in the heart and the kidneys. So you will want to spend some time on this figure, figure 5.4. This figure shows the different places in the body where the renin-angiotensin-aldosterone system works at, and how really it is a cyclic reaction. And in this case, we're going to start at the kidneys. The kidneys have a major function in maintaining serum sodium levels, and it's very sensitive to changes in blood pressure and volume. And here you have a decrease in blood pressure, a decrease in extracellular fluid, decrease in serum sodium, increase in urine sodium concentrations. Those factors are going to cause the kidney to produce renin. And then renin gets into the vasculature, begins acting on angiotensin 1. You have the lungs that produce what's called ACE, angiotensin converting enzyme, which acts on angiotensin 1 to produce angiotensin 2, which goes to the adrenal cortex. The adrenal cortex secretes aldosterone. Aldosterone acts on the kidneys to increase sodium and water retention. That's going to cause an increase in extracellular fluid, increases the blood pressure, the angiotensin 2 acts on the arterioles to cause vasoconstriction, and the vasoconstriction increases blood pressure because you have a smaller volume in which the same amount of fluid can move through the vasculature. So these are hormone mediators. The angiotensin 1, the angiotensin 2, the aldosterone, and overall result is to increase reabsorption of sodium and secretion, or increase sodium retention or reabsorption, cause secretion of potassium, and finally to increase blood volume and blood pressure. Now, what this slide is simply a previous version of the same figure on the previous slide, and you can just look at it. It's bigger picture, less words, and in the notes section you can read through that. Gives you a little better, or a better idea of what's going on, a better explanation, or more of an explanation. All right, the antidiuretic hormone system, simply called ADH sometimes. This is critical in regulating water balance throughout the body. ADH, which you see here, kind of in the middle of the slide, is going to be secreted by the pituitary in a response to increase plasma osmolality up here or decrease plasma volume. You have these two initiating events that signal receptors that act on the hypothalamus. All right, here's the hypothalamus, and that tells your body that you are thirsty, and hopefully you will increase your fluid intake. All right, increase thirst and fluid intake, and that will have a direct effect on decreasing the plasma osmolality. All right, when you feel that you are actually thirsty, you're already dehydrated, and it's actually a good thing to reach for water and not a fluid that has a lot of solutes in it, like sugar or chemicals or salt. So your fruit juices, sodas, coffee, if you drink it like I do, with lots of sugar in it, sports drinks, what you want to do is to increase your water so that you can decrease the concentration of the solutes that are in the plasma, and that is going to decrease the plasma osmolality. All right, activation of the hypothalamus here signals the pituitary to release the ADH. That goes to the kidneys and causes water retention. All right, water to be retained, that leads to a decrease in plasma osmolality because you still have the same amount of solute, but you're increasing the water concentration. And then here, that's going to lead to an increase in plasma volume. So, when you're thirsty, drink water. Not to say that you can't drink other fluids, soda, fruit juice, but it should be limited, and it shouldn't be your first choice when you actually feel that you are thirsty. All right, now moving on to actual electrolyte imbalances, specifically sodium, potassium, calcium, phosphate, and magnesium. The next 5 slides are going to look at different electrolyte imbalances. These can be high or low. Sometimes a person can have an issue with just one electrolyte, but other times if one electrolyte is imbalanced, it naturally causes another electrolyte to become imbalanced. There is a lot of information on the following slides, but what I want you to know is the purpose of each electrolyte, which is going to be at the top of each slide, and then the causes. As far as the actual manifestations of the different electrolyte imbalances, hopefully some of those will just come naturally to you by understanding what the purpose of the electrolyte is or does in the body. But we will specifically come back to those as we get into the body systems later in the semester. The first one is going to be sodium. Sodium is necessary for regulating water balance and osmolality. I've hit this several times already. Also, conduction of nerve impulses, participation in cellular chemical processes, and remember, again, that sodium is the primary extracellular ion or electrolyte. So, you'll want to know this information, but in all reality, it's probably going to be focused on regulating water balance. So, too much sodium leads to what's called hypernatremia. Too little sodium is going to be hyponatremia. The causes of hypernatremia occurs with a high amount of fluid replacement therapy or oversecretion of aldosterone. You simply have an increase in sodium that is typically caused by a water loss. Now, rarely does hypernatremia occur with diet. All right, yes, a person can have a high diet or a high salt diet. That's often can lead to high blood pressure. If you have one high salt meal, like you go to Flying Pie Pizza and have their wonderful pizza that is so delicious, but definitely high in salt, and you pig out on it because it's so good, All right, the next morning you might have a slight issue with water displacement. And if you wear rings, then your fingers might be swollen in the morning such that the rings are a little uncomfortable to wear. All right, that is not true hypernatremia. That's simply you eating a little too much salt at one point in time. But with infants, you can have hypernatremia occur with food, all right, with diet, and typically it's going to be under 2 years of age. And I read a story, it's probably close to 20 years ago now, 15 to 20 years ago, about a couple in Great Britain who was charged with the death of their child. The child was under 2. I'm thinking it was under even 1 year of age. And this child died because of a high salt diet. The parents simply gave it anything and everything it wanted, everything that the mom and dad were eating, and it was just poor food. There is a reason why, if you happen to try baby food, it's bland. Right? We think it's bland because we're used to all of the extra flavoring, particularly the salt. Babies don't know anything different, so they're fine with eating the bland baby food. So, gotta be careful with that. So, hypernatremia, increase in sodium due to a water loss. Hyponatremia, decrease in sodium intake, excessive amounts of water. So if you drink huge amounts of water, you can actually dilute the salt that's already in you, and then you don't have the proper concentration. And decrease in sodium intake, you know, if you are doing a lot of extra work in the heat, you're sweating a lot, that type of activity, and you're just eating lettuce, all right, then you could actually have some issue with hyponatremia because of diet, but it doesn't happen that often in terms of diet. And you have the different issues with the manifestations, which again, if you understand the issue and of what sodium does, you should be able to get that. But what I want to point out on this next slide is that in both cases, with hypernatremia, you can have hypervolemia. You can also have hypovolemia, which they're opposites. High volume, low volume, in the same scenario. With hypervolemia, with hypernatremia, it's a strict increase in sodium. And so the extracellular fluid will increase. That gives you hypervolemia. You can develop hypovolemia with an increase in sodium level along with a loss of water. And so then the extracellular fluid will decrease and you can have hypovolemia. Hyponatremia, again, same thing, hypervolemia, too high fluid replacement level, thereby diluting or decreasing the sodium, leading to hypervolemia. Hypovolemia, you have a sodium loss, so you have huge amounts of vomiting, diarrhea, burn patients, and that leads to hypovolemia. All right, potassium. Potassium is found primarily in cells, and it's critical in maintaining the resting membrane potential for nerve impulses. All right, so critical for nerve impulses and intracellular fluid osmolality. All right, the primary intracellular electrolyte. So kidneys are important in maintaining potassium levels. If you recall with the renin-angiotensin-aldosterone description, that's going to lead to the kidneys dumping potassium while trying to hold on to sodium. So the cause of hyperkalemia, all right, too much use of whole blood, replacement potassium, burn patients, and then massive crushing injuries. Let's see, also excessive surgery because of damaging cells. You can have hypoxia, and then manifestations, muscle weakness, restlessness, intestinal cramping, diarrhea, all issues that come along with nerve impulses. And then hypokalemia, reduced intake, excessive loss in sweat, urine, stool. So there's going to be other physical issues going on for you to have excessive loss in sweat, urine, stool.